All right, in this lesson today, we're going to talk about the algebra of functions. And so just recall for a moment that when we write an equation in function notation, or a function that is, when we're solving a two-variable equation for y, we can write y as a function of x. So we have y equals f of x. So we're really just replacing the y with f of x. And that's kind of useful here because that way I can differentiate between these two functions. So if I wanted to evaluate a function, if I wanted to evaluate f of x equals 3x plus 5 for x equals 2, how can I tell that the x is equal to 2 here? Because it's basically replacing the x. The 2 is replacing the x. So we would have 3 times 2 plus 5. And then let's show our work vertically. Here we'd have it 6 plus 5 equals 11. Is that what you got? Okay. What about g of 5? For g of 5, I'm going to plug in the 5. 2 times 5 minus 3 gives us 10 minus 3, which is 7. And then what about this one, the at symbol? Well, essentially, this is just replacing wherever x is. So we have 3 at plus 5, 3 times at, right? And that's it. So that's evaluating functions. And then the algebra of functions is just like when we were creating rational functions, we took two functions and we divided them. So all this means here is we're going to take f of x and we're going to add g of x. Here, we're going to take our f of x and we're going to subtract g of x. What do you think we're going to do for this one? Yes, multiply f of x times g of x. And for the last one, we're going to take f of x and we're going to divide it by g of x. And that's where we were getting into the idea of the restriction on the domain. And basically, with these algebra of functions, we can create new functions by adding, subtracting, multiplying, and dividing functions. So here, if I have f of x plus g of x, I'm going to take whatever f of x is, and I'm going to add g of x. So I get x squared minus 9 plus 2x minus 6. So I'm taking a quadratic function, adding a linear function. How do I know that this is a quadratic function, by the way? What about it says I'm quadratic? X squared. What about this tells you it's a linear function? Yeah, it's x to the first power, in fact. So we call this a first degree, second degree. Now, if we add these things together, what would you get if you wanted to write this in standard form? Minus 15. So what you did there was you combined your like terms. And by the way, that's all that is. Okay, so that's just our new function. Sometimes you've seen on Connect Math and in the notes, you might have seen h of x equals f of x plus g of x, and then we could call this a new function h of x. It doesn't say that here, but that would be an option. Now, if I added the two functions together, it would be the same thing as if I take f of 0 plus g of 0, or I can plug that into the very new function that is those two things added. So what would be f of 0 plus g of 0? Wherever you see an x, what are you replacing it with? Yeah, 0 squared plus 2 times 0 minus 15 gives us negative 15. Excellent. Okay, I didn't really go in order, but let's go to the subtraction now. So if we wanted to subtract, we have x squared minus 9. That's the first one. Subtraction order matters. If I'm going to subtract, it's really important that I subtract. If I'm going to subtract g of x, I want to subtract the whole thing. So I'm going to put 2x minus 6 in parentheses. Does anybody know why that's important that I put those parentheses there? So what do you need to do with this negative sign? You want to distribute the negative. So now we get minus 2x, and instead of minus 6, we would get plus 6. So when we simplify that, we get x squared minus 2x minus 3. Does everybody see how I got that? Now, if I want to find f minus g of 3, that would be f of 3 minus g of 3. Again, I could put those 3's into each function and then subtract them. Or since I have this new function, which is f minus g of x, I can put that 3 in here. So I'm going to have 3 squared minus 2 times 3 minus 3. 9 minus 6 minus 3 equals 0. Great. Okay, so if I got y equals 0, then what is this on this graph? Whenever you have y equals 0, you always have an x-intercept. I just have to bring that up because anytime we have a 0 that's like, oh, yay, 0, that's a special point. When we had here x was equal to 0, when x equals 0, what kind of point is that? Yes, the y-intercept. Okay, now let's look at the multiplication. So here we're going to take f times g of x. F of x times g of x. And so I'm going to take x squared minus 9, and I'm going to multiply that by 2x minus 6. And we could FOIL all of that out. Maybe that would be a good idea. But essentially, yeah, either way. Well, why don't we just FOIL it out just to make sure we know how to FOIL it out. Okay, so if we FOIL, we have 2x cubed times what? Negative 6x squared. Yes, because we're FOILing, right? And then minus 18x plus what? 54. Good. Okay, now if I want to find f times g of 0, I could have plugged them into either one and multiplied them, or I can plug in f times g of 0. I can plug in the 0 here, and what will be left? 54. So that means that's an x equals 0 means this would be a y-intercept, just for fun, okay? Now what about this division one? F divided by, so this is f of x divided by g of x. So f of x is x squared minus 9. G of x is 2x minus 6. Now, whenever it comes to a fraction, don't you want to ask yourself if you can simplify? So what do you think? Can we simplify? What would we need to do to find out? Yes, we would want to find, well, we would want to factor. So if I factor this, who can tell me what the factors are? X plus 3, x minus 3, and then how would you factor the denominator? 2 out, x minus 3. And so do you see that you can simplify that? And this is what they're going to ask you on Connect Math as well. What number, even though I can simplify that to x plus 3 divided by 2, what is my restriction on the domain? What would give me 0 in the denominator, even though it canceled? 3. So we would still maintain that you cannot have x equals 3, even though it canceled out. Now, if I say f divided by g of 5, this would be f of 5 divided by g of 5. But I can also just put that into this equation here because this is the simplified version. If you start out with finding f of 5 and then divide it by g of 5, you're going to get the same thing, but it's going to be able to reduce. So because 5 is not 3, I don't have that restriction. I can use 5 as my domain. I'm going to have 5 plus 3 divided by 2, which is 8 divided by 2, which is 4. Okay, so f divided by g of 5 is equal to 4. Any questions on that so far?